Hi, am I audible?
Yes, you are audible, sir.
Yeah, thanks. Aditya, can you hear me? You can unmute and talk, not a problem.
सर आपकी आवाज आ रही है।
Hello.
हाँ नमस्कार सर, आपकी आवाज आ रही है अभी।
Okay, so yeah, I don't speak in Hindi, but I can reply in English.
ओके सर।
Yeah, question number 2 and 4 from assignment, that is about SL2 representation theory. So you can look at this is just your class here. So there is a book by Henderson, okay. So representation theory introduction through GLN. So this is actually a wonderful book. So you can find similar problems in that book. So maybe I will send you the link here in the chat. So any basic book on representation theory of semi-simple algebras will begin with representation theory of SL2. So you will be able to find similar problems in any books. But anyway, I am giving you one very specific book, this representation theory through this GLN. Okay. So this one you can have a look, and then yeah, you can find many problems there related to SL2 representation theory.
ओके सर।
So in assignment 6, question number 2 about how many submodules of SL2. Satish, you have writing pad?
Yeah.
Do you want to answer? Do you have this access to the assignments?
Yes. Right, you're right. So assignment 6, question number 2 is if lambda is 3 epsilon 1 plus 2 epsilon 2 plus epsilon 3, let V lambda be the corresponding irreducible representation for SL3. Then we are asking what is the dimension of a weight space corresponding to the weight
That is not.
epsilon 1 plus 2 epsilon 3.
Satish, he's talking about take SL to C, take 6 copies of SL to C.
Okay.
And then the number of submodules in that. So take direct sum of SL2, 6 copies.
Okay, let me share screen and then.
Yeah. So basically, the submodules of this direct sum, so they will correspond to. So this is just the same copies, na? SL2C, 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 6 copies.
Yeah. Is my screen visible?
Yeah.
Okay. So, you repeat the question. We have SL2C.
Yeah. Take V to be SL2C.
V is SL2C.
Yeah, which is a joint representation of SL2C.
Right.
Take V, 6 copies of V. V direct sum 6.
Okay. V direct sum 6.
And the number of submodules
okay.
of this one.
Okay. So this is adjoint representation. right? So now if we call W to be V direction 6, what are the number of submodules? So if we recollect Weil's theorem, Weil's theorem, it says no. So you could think of SL. So V power 6 has a semi-simple Lie algebra, like 6 copies of SL2C, diagonal copies of SL2C. Any submodule for this, when you think of W as a SL2 module, a submodule for this is basically an ideal for the semi-simple Lie algebra SL2C direct sum 6. Okay. Weil's theorem implies submodules of W are in one-to-one correspondence with ideals of the Lie algebra, of the semi-simple Lie algebra SL2C direct sum 6. And you know what are all the ideals of SL2C, right? So it is going to be given. So there are this. So you think of this SL2C as a 6 by 6 block matrix. Okay, it's 3. So each of the diagonal block, so each non-diagonal block is 0. And the diagonal, each one is a copy of SL2C, right? So this is how you should think of it. Here, an ideal for this matrix. So okay, so this is each one is a 2 by 2 SL2 C matrix. Each diagonal entry, right? So an ideal is basically whether you choose one diagonal block or not. So there are six possibilities. So there are 6 dashes. If you choose to put SL2C here, that is one possibility, or you could choose to put 0. Okay, so you have 2 possibilities for each direct summand, and so in total you have 2 to the 6 different copies, right? To each block you have 2 possibilities. Either you put a 0 or you put a SL2C. Is that making sense? Am I there?
Continue, sir. I am understanding.
Yeah, that's all. So the answer is 2 to the power 6.
Okay.
Hmm.
But
See,
sir,
SL2C is simple, right?
in
So it doesn't have any ideal.
but in assignment there is accepted answer is 8 to the power 2, sir, not 2 to the power 6.
Yeah, 8 is 2 to the power 3. 8 to the 2 is 2 to the power 3 squared, which is 2 to the power 6.
Okay.
Hmm.
Okay, sir.
Is it? Okay. Can I turn off my screen sharing, sir?
Yeah, fine.
Okay.
Do you have
Can
any
you,
other question?
sir, can you please explain question number 4 from assignment? एक minute, sir.
You can show it in the screen if you want to.
That's that part question. If my screen is visible, एक minute, sir. Back. So that question, I think it is visible. V be a finite dimensional SL2C module whose weight and their multiplicities are given by the following table. Question number 4 from assignment is assignment 7, question number 4.
Satish, you have the question?
V be the finite dimensional SL2C
No.
module.
I have access. I'm asking Satish.
No, I don't have the questions now. Like,
I can-
let me open
I can share. Just
please.
see the question here.
Okay,
The multiplicity table is given.
right. Okay. Yeah. So what is the what is your doubt here, Aditya?
Sir, please explain whole question.
You want
from-
you want the solution, or you want to understand the question only?
No, sir, I want solution.
Okay. Just a second. So this is just peeling off the usual peeling off argument, no? So do you remember how an irreducible? I mean, do you know what are all irreducible representations for SL2C? Finite dimensional irreducible representation.
I think V lambda is the set of polynomial whose homogeneous polynomial in degree in two variable and degree.
Right. That is right. So what will be
weight.
so let's say, so what are all highest weights, possible highest weights for SL2C?
That is, you just copy this table at it. Better
Right.
you share your screen.
Okay, sir. All right. I'll share my screen. Do you see the screen?
Yes, sir.
Okay. So let me copy the okay, before going into the question. So we have this Lie algebra SL2C, right? What are all irreducible representations? Irreducible finite dimensional representations. So they are in one-to-one correspondence with non-negative integers, right? Aditya?
Yes, sir. You can proceed. I am understanding.
No, let us keep it interactive.
Okay.
Otherwise, you may get lost. So let stop me whenever you don't understand. Okay. Finite dimensional representations for any Lie algebra, any finite dimensional semi-simple Lie algebra are parameterized by what are called highest weights, and highest weights or dominant weights in SL2C case are nothing but non-negative integers. Okay, so 0, 1, 2, 3, and so on. So given a non-negative integer, I have an irreducible representation, and if I have two different non-negative integers, those two highest weight representations, Vk and Vs. So if S and K are two non-negative integers, and if K was not equal to S, then Vk is not isomorphic to Vs. Okay, and this gives you an exhaustive list of all irreducible finite dimensional representations. All right. Now coming to what are the weights? Okay, so Vk, if you consider this representation Vk, उसमें weights are k minus 2 k minus 4 all the way up to minus k. All right, and the multiplicity of each weight is 1. Multiplicity of each of this weight is 1. All right, now let us come to the question. What does the question ask? So suppose you have a finite dimensional SL2C module. So it will be a direct sum of VKs, right? VK some number of times. K comes from some multiset. Right. Now, what is the data that we know about V? We know what are all the weights that appear in V, and we know their multiplicities. Weights and multiplicities. So the weight minus 5 appears 6 times, minus 4 appear twice, minus 3 appears 6 times, minus 2 appears thrice, minus 1 8 times, 0 5 times, and then symmetrically 1 appears 8 times, 2 appears 3 times, 3 appears 6 times, 4 appears twice, 5 appears 6 times. Okay.
Multiplicity means, for example, V minus 5 has 6 copies in.
Correct.
Okay.
No. It says see what is a weight of a weight in a representation. It is eigenspace for the Cartan subalgebra, right?
Okay.
Right. It is, I mean, eigenvalue for the Cartan subalgebra. So multiplicity is dimension of the eigenspace. Okay. So how many times the eigenvalue minus 5 appears for the action of the Cartan subalgebra element H. H is there, no? This 1, 0, 0, minus 1. Is action same?
Can you repeat again?
Huh?
How many times minus 5 as eigenvalue? Repeat.
Yeah, so H acts on V, right?
Yes.
You can think of H as a linear operator from V to V, right?
Okay.
Now this, so multiplicity of the weight. So first weight for this action is nothing but the eigenvalue for H. Okay, weight is nothing but eigenvalues for the action of H on V. And multiplicity is what? It is the dimension of the eigenspace or multiplicity of the eigenvalue minus 5. Dimension of the eigenspace corresponding to the eigenvalue minus 5 in this case. Okay, is that clear?
Okay.
Okay. Now coming back. So, 5 is a highest weight, right? Meaning it is the largest weight that appears here. And so V of 5 should appear in V, right? V of 5 appears in V how many times? 6 times. This is the eigenvalue, the multiplicity of the eigenvalue 5, right?
Yes.
So once V5 appears 6 times, what do we know? The eigenvalue 5 appears, so in V5, eigenvalue 5 appears 6 times. I mean, in V5 it appears once, but then when V5 appears 6 times in V, 6 times in V, the multiplicity of the eigenvalue 5 that is contributed by V5 in V is 6. So is 3, so is 1, -1, -3, and -5. So here 6 is gone from V5. This 6 is gone. Here 2 remains. Here 2 remains. Here nothing remains. Nothing remains. All right. Now what we have done is we have peeled off V5. We have peeled off 6 copies of V5 from V. Acha?
This process I can't understand. How this we cancel with these copies?
See, you have V is direct sum Vk, right? Let's write this as V K1 direct sum V K2 direct sum, let's say V Kn. Okay.
Okay.
So let K1, let us further assume that K1 is the largest, K2 is the second largest, and so on. All right.
Okay.
Yeah. So what can you say about the largest eigenvalue of V, the largest weight of V? That should be the largest weight of VK1, right?
K1.
Yeah. So it is
Yeah.
K1, exactly. So that is what we are doing. So we are starting with the largest weight of V, which is 5. And so we are sure that V5 appears in V. And how many times does it appear? It appears 6 times.
6
Is that
times.
right?
Yes.
Yeah. So K1 through K6, VK6, all of this is V5 only. So VK1,
Okay.
VK2, VK3, VK4, VK5. All of these modules are V5. And how many? So is that clear?
Yes.
Yeah. So we have found out what is K1, K2 up to K6. Now what will be K7? That
K7
is
is
the
the
next
next
question.
lower weight.
What is the remaining weights that are there in V? That is what we have to
4.
see. The remaining weights are, -4 appears twice, -2
Okay.
appears thrice, -1 twice, 0 5 times, 1 twice, 2 thrice, and 4 twice, right? So
Okay.
the next
Okay.
highest weight that appears in V is 4,
4.
and it appears twice, right? So V4 appears twice in V. And what are the weights in V4?
2.
No, that is multiplicity. What are all weights that appear in V4? 4, 2, right? We saw, right? When we have Vk, the highest weight that appears in Vk are K minus 2, K minus 4 up to minus K, right?
Okay.
So the weights that appear in V4 are 4, 4 minus 2 is 2, and then even subtracted 2, it is 0, right? So these are the
Okay.
weights that are going to appear
Okay.
in V4.
I understand.
You understand? And then how many copies of V4 are there? 2 copies of V4 are there, right? So this
Okay.
two copies come out. This 3 becomes a 1. Here 2 comes out, so it becomes 3. This becomes 1. This becomes 0.
Okay.
All right. So K7 and K8, K7 and K8 are 4, right?
Okay.
Now what is remaining multiplicity? Remaining is minus appears once, -0 appears thrice, 1 twice, and 2 once. So what is the
Okay.
next irreducible representation that is there in V?
V3.
V2. V3 has multiplicity 0.
Okay. Okay.
V3 has
V3.
multiplicity 0, right?
Okay.
So V2 is the one that is next non-zero, right?
Yes.
So, and what is the multiplicity? It is 1.
Yes.
So what we can conclude? We can conclude V2 appears once. Appears once in V. And so this 1 will be taken by this V2, right? But then what are the other weights of V2? So the weights of V2 are 2, 0, and -2, right?
-2. Okay.
So from 0, you have to remove 1 contribution. So you'll be left with 2. From -2, you will have to remove 1 contribution. So there is no more weight of -2 now.
Okay.
Now what is the next representation that is there? So what K9 is 2. What is K10 now?
K10 is 1.
1, right? So K10 is 1. And how many copies of 1 are there?
2 copies.
2 copies of 1 are there, right? So V1 appears twice. And so if we remove the contribution of V1 twice, then the weight space 1 will become empty. The weight
And
space
minus
0, will that affect the weight space 0? No, right? Because
no.
what are all the weights in V1? It is either 1 or minus 1,
-1.
right? So this
Yes.
2 is also gone.
Okay.
Sorry, this is 0. Yeah, this 2 is also gone. Now what is left in V? V0 is left in V. And how many times V0 appears?
2 times.
Yeah, twice.
Okay.
2 times. Now what is the question? Let's see what is the question. The question asks, the options are the multiplicity of V0 in V2. Sorry, the multiplicity of V0 in V is 2. That is
2.
right.
Okay.
So, the multiplicity of V3 in V is 1. But there is no V3 here, right?
Yes.
So option B is false. The multiplicity of V2 in V is 1. Is that right?
Yes.
Right? Yeah. So option C is correct. And option D, multiplicity of V4 in V is 4. Is that true? What
No,
is the
it is
multiplicity?
twice. 2.
It is twice, 2 times, right? So this is
Okay.
option D is wrong.
Okay.
That's all.
Okay,
Was
thanks.
it clear? Okay. Do you have any other questions, Aditya? Hello?
Can you hear me, sir?
Yeah.
I am reading a book in which I read a lines which says that line between the root and the Dinkin diagram depend upon the angle between the roots. And matlab how can we say that on angle lines is depend on angle between root?
Okay. So this I think Venkatesh sir will answer.
So
Yeah.
can I state again? Can I state the question again?
Yeah.
Sir, I read a line in book which says that
Which book?
yes, sir.
Which book?
I am read sorry, a book Fulton's book.
Okay. Yeah.
Uh, Sir, which says that lines between the root and the Dinkin diagram depend upon the angle between the roots. How can we say that lines between two root depend on the angle?
So that is the way you actually draw the line, no? The number of edges that you put depending upon the angle, no? That pi divided by. So okay, what is how do you draw Dinkin diagram?
Uh, Sir, we use the relation 4 cos square theta.
Yeah, there that cosine actually depending upon the angle only, no?
Okay, so here it wants to say that value of 4 cos square theta will give the lines between the roots.
Yeah, exactly. Like so, for example, refer this Humphreys where the table is actually given. So you can actually read it from the table. What will be like? So given two roots, how many edges will be there, and how to put arrow. So arrow will be towards always short root. Okay.
Long root to short root.
Yeah, long root to short root, and then the number of edges between two vertices. Okay, those simple roots. So that is basically you will be calculating alpha beta and beta alpha, na?
Okay.
So the product, inner product. The inner product is actually recorded in the cosine of that angle between the two roots. So have you seen Humphreys?
Humphreys, but not, sir. I am reading only
Yeah, it's the same.
Wilden's book only.
Humphreys actually works out the table. That is why I'm asking you to look at Humphreys. The table is very explicit there. I don't have a copy now.
No, sir, I have a copy of
Yeah, you
this.
then look at chapter 3 that on root system. He actually starts the even the chapter with this very explicit table where he actually kind of determines what are all the possible rank to root system. Na? So
Yes, sir.
the irreducible rank to root system. So you can determine by calculating the angle between alpha beta only because there are lots of restriction.
I think your some back camera is not working. I think you are saying about this diagram.
Yeah, that is the diagram I'm talking about.
Okay, sir.
But this is Humphreys.
Yes, sir. Yes, sir.
But you go the beginning of the chapter where the table is given.
I am seeing, sir.
Yeah, go to the
Starting in chapter 3.
3.1 or 3.2. I don't remember.
Yes, sir. Just table, I think.
Yeah, that is the table. So that actually tells about what happens. Yeah, between two roots alpha beta. So you
Okay, sir.
see that the angle is somehow like so. Of course, when you take alpha beta to be simple root, both are positive. So then only one of the thing will happen, and you can see that types like basically G2, B2, C2, whatever those are all recorded by the angles.
Okay, sir.
Yeah, that's basically the cosine of that. That you are also calculating only the cosine of the angle pi divided by mij. Calculating the inner product is same as calculating angle in some sense.
Okay, sir.
Sorry, where are you from? What are you
Sir,
doing?
sir, my name is Aditya Ojha. I am working in Government Degree College, Palampur. Palampur in Himachal.
Oh, okay. You are already lecturer there?
Yes, sir. Yes, sir. I am assistant professor.
Oh, okay,
Um,
nice. Okay.
sir, I want to know. I am doing. I want to do research in representation theory, and it's connected in special functions. So, is this a good area?
Representation theory in general is a very good area. Like there are lots of connections with physics, number theory, and so on. But special functions means so you are coming from like Lie group's point of view, analysis point of view.
Sir, once I read a book called Willard Miller. It is title is special function. So in that book, he use representation theory, and when we try to represent group by the help of matrices, then a special function appear as a element of that matrices. So I am read some part of that book, but not in deep, sir.
Okay, okay, fine. I guess yeah, towards this direction, I guess E.K. Narayanan from our department, IAC.
Okay,
So
sir.
he's
I
he's an expert.
okay, sir.
Maybe if you have a very specific question related to special functions, you can write to him.
Okay, sir.
He may answer. Yeah.
Thanks, sir.
Okay. Yeah. Thanks. Do you have any more questions?
No, sir, I am studying. If there is any problem, then I will write through mail.
Sure, sure. You can contact us. So you can either write to Satish or write to me. No problem.
Okay, sir.
So yeah, you if you have any questions related to assignments, you can write to
No,
even not
no.
only related to assignment, anything related to the material, course
Sir,
material, you can write to us.
course material is very good. Lecture is also very good, and with ads of book, it becomes very effective.
Yeah, I'm happy that picked up. So you are
I,
just doing it on your own, just for the sake of
sir,
learning.
I am doing only for my, sir, personal
Yeah,
interest,
yeah, I
sir.
understand. Because you don't, I don't think you have any course related to this, no?
Yes, sir. Yes, sir. I am only teaching in undergraduate courses.
Yeah, yeah, I understand.
Mm. So,
Only some of the ICERs actually they teach bit of Lie algebras, but not in colleges.
okay. Okay, sir.
Mm.
So, sir, there is personal question. Can I ask or I ask
Yeah,
in?
sure, yeah, sure.
Sir, I am not a PhD. I am only MSc MPhil in mathematics.
Mm-hmm.
I want to do research in area in Lie algebra or any other related field. Once I was trying to, I was enrolled in PhD, but due to some personal reasons, I am not able to continue that. So I am not doing research in now. So,
Okay.
but I want to do research in that area. So I second time I appear for this exam, sir. Once I have already passed this exam.
Mm-hmm.
Last year I also gave that exam, but my marks is not good. So I again trying to study, not for marks purpose. I want to uh, understand topic fully, so I
Yeah, yeah.
again reappear
Mm.
for exam. uh, so there is any scope for me to doing research.
Not, yeah, doing research, like it will be easier if you do full time. Okay.
Okay.
So part time will be actually somewhat difficult, and because you already see that the demand is more here, huh? So you have to
Yes.
really spend lots of time in picking up the material. So it usually takes at least 2 years to just to pick up necessary material, even to read some advanced papers. Okay.
Yes, sir.
So that is why, like, it's my personal opinion. Okay. Or otherwise, like, if there is somebody nearby. So you said you are from Himachal.
Himachal.
Yeah, it's, I don't know, like IIT. I don't think anyone is there. Work.
Either Aisar Mohali is there in
Yeah,
surrounding. There is
Aisar
Aisar Mohali.
Moghali, Tanushri is there. Tanushri Kandai. So she works in representation theory.
Okay, sir.
But that's why, like, if you can meet someone who is working in, who is doing research in representation theory, and then discuss with them like on regular basis, weekly once or twice. So that would actually help you to do research.
Okay, sir.
But
But
otherwise, I'm not very sure. Like, it will be easier to continue like part time. But
okay,
right
sir.
now you are already having job, no? So I don't know. Like, so usually I hear that they give 2 years study leave if you are interested
Um,
in doing research.
okay, sir. I will try
Maybe that you
whenever.
can explore and then see, like, but that is, I don't know whether they give the holidays study leave with with salary or without salary. That is also you have to see. But
Okay,
if
sir.
you are interested in joining any of these institutes, then you have to clear CSAR. And
Sir,
then,
I still not want to join anybody, but I am doing my own research. I try to understand subject, and in near future I try to do research in that area.
okay.
So
So then in that case, that why don't you just try to participate in some of these workshops that happens related to these topics? Like we always organize many workshops, conferences. So
okay, sir. Next there will be ATM school. I will surely join in
yeah,
ATM
exactly.
school.
We last year also we had this school on Lie groups and Lie algebras. So every
Okay.
year we try to organize something. So maybe you can try to join and then see.
Okay, sir. I will try next time whenever there
Yeah.
is.
That may be like one way to go about it actually. Try to
Okay.
attend some proper try to learn advanced materials. And then by the time you just if you talk with somebody, then you already kind of you get into the topic.
Okay, sir.
Okay, then. So yeah, if you don't have any more questions, maybe we can wind up. Not a problem.
Okay, sir. If there is any problem, then I will.
Sure. You write to us. Yeah, no issue.
ठीक है sir. Okay, sir.
Yeah.
Can we wind up, sir?
Yeah, sure. We can wind up. Yeah.
Okay.
Thanks. Thanks for this.
Thanks, sir. Thanks
Yeah.
for all.
Thank you.
Thanks.